Hello and welcome, Nord Anglia, and thank you for joining us for our MIT abstract on glaciers and honey with MIT graduate student Joanna Millstein. I'm your host, Fatima Hussein, and I'm a PhD student at MIT studying ancient Earth. Now, before we begin, I'd like to cue our listeners into what an abstract actually is. An abstract is simply a snapshot of a greater work of research or writing. And what's exciting with this series is that you have the ability to ask our amazing speakers questions about their research. I'm really excited today to welcome our speaker and our guest, Joanna Millstein. She's a glaciologist. She studies in the same department as me, and I am a huge fan of her. Welcome, Joanna.
Thanks so much, Fatima. I'm so happy to be here, and I'm so excited to share with all of you Nord Anglia students a bit about my research, how I became a glacier scientist, and some of the questions that I think are really exciting. So let's get started. Super basic. Let's start off. What is a glacier? I don't know about you all, but when I was in school, when I was in elementary school, and middle school, and high school, this was my mental image of a glacier. I thought that a glacier looked a little bit like this. So a few things first. Let's start with some definitions. To distinguish a glacier from just a pile of snow, one critical aspect is that a glacier has the ability to persist from year to year. And the other critical insight is that glaciers, unlike piles of snow, which melt in the sunlight, they move under their own weight. So when I think of glacier, I think of snow falling and compacting into ice, and ice moving through the mountains, carving out valleys, flowing into the ocean where it melts and breaks off. And so the other critical question here is, why do we care about glaciers, right? So you can all see my cursor. I'm going to use it a little bit during this talk, right? So we care about glaciers because it's really important to understand how these glaciers move and change in response to the global warming, and then how melting glaciers and breaking glaciers is going to impact sea level rise. So today we're going to go on a tour a bit around the world, and we're going to move through and explore some of the biggest glaciers in the world, which are actually ice sheets, assortments of many different glaciers. So starting in this red circle, we're going to begin with Greenland, and then move over to the orange circle into coastal Alaska. And then finally, we're going to talk a bit about Antarctica in this blue circle. So we're really covering the globe. We're going all over the place. And beyond these three regions, glaciers exist on every continent except Australia, I believe. So they're everywhere. These are just three places that are near and dear to my heart. So we'll begin by flying to Greenland. This little orange pin shows exactly where we are on the map. And this is when I saw a glacier for the first time. Here on the western edge of the Greenland ice sheet, I was so amazed by how big this landscape was. So you can see that ice goes all the way to the horizons, and it's carving around these rocks, exposing bedrock underneath the ice. But I was really struck by all these cracks on the surface, right? Look at these. They're just moving across the ice, and they're huge. We're pretty far away, but this wasn't smooth or steep in the way I expected glaciers to look, just like that cartoon I showed you, right? And so this first time seeing a glacier totally changed the trajectory of my life and my career. So here I am in this pink coat on the summit of the Greenland ice sheet. And fun fact, the summit of the Greenland ice sheet is more than 2 miles above sea level. So walking around, you get pretty winded. This was in 2014. I just finished my freshman year of college, and I had been invited on this expedition as a geology major to help survey glacier change using global positioning systems. We'll talk about that a little bit more. But this was totally unexpected. This is not something my family could have said, oh yeah, Joanna really wants to study glaciers of the Earth. When I was in high school, I grew up in New York City and Washington, D.C. and suburbs in that area. And I competed in a competitive math team. So this is me right here. So I traveled around the country with my math team, visiting different universities. Actually, we went to MIT in 2010. So that was my first time seeing MIT. And it was really fun and really difficult. I was not the star of the math team, but I had a lot of fun just kind of puzzling through different ideas. The other thing that I spent a lot of time doing in high school, and that's still really important to me, as you can see from the bikes behind me, is bike racing and riding my bike. while competing is not really something I do anymore, I love riding my bike. It's such an amazing way to explore the world around you. And whenever I go somewhere new, I try to get my hands on a bike because it's a great way to feel like you understand a sense of place. It's a good way to get to know your surroundings. So I love biking more than just a form of competition. It's a mode of transportation. You can always bike to your nearest ice cream store. So that's a really big part of that as well. But back to Greenland. It's still 2014 on this first expedition. And when we were flying into the ice, this is again on the western coast of Greenland, I was struck by all the grass. Do you see this here? This is all grass. This is moss. Where are the glaciers? Where's the ice? I thought Greenland was just a big ice sheet. There's all this exposed bedrock, and you can see it's been scraped by retreating, melting glaciers. You can kind of see these lines here, right? And then finally, these little melt ponds from ice that's melted away, and it's really fresh water flowing into the ocean, which is way further out that way. So we'll fly a little further inland. Here we go. Ice has appeared. And so now we're moving over mountains and looking at this really smooth, almost soft looking ice, right? This is such a weird material. It looks like marshmallow to me. So I was so excited to see this. I was like, are we going to land our helicopter? Are we going to walk on this? But then just over this ridge, this rugged landscape is covered with these huge cracks in the surface, much like that first photo I showed you. So these are known as crevasses, and they run across the glacier surface and make these really big cracks and fractures in glaciers. And we don't really know how deep they are oftentimes. It's hard to walk up to the edge. We can't land a helicopter here. It's too dangerous to ski over here. Can't walk up to the surface and look in it and see how deep it is. So this is another, we'll get into like why I really like crevasses soon. But this first trip, again, really inspired me, changed a lot of my research interests, and has led me on this path to becoming a PhD candidate in glaciology. So I was struck by these two things. One, has Greenland always been so green? I couldn't believe how much grass there was. And I couldn't believe how small some of the glacier landscapes felt, really. And so the other point is that glacier ice didn't look like the ice cubes in my freezer. You know, when you're pulling out a tray of ice and you put it in a glass of water, maybe you drop an ice cube on the floor and it just shatters and then it melts and it's really clear. This doesn't look like that. I thought all ice was ice. So we'll get into that a little more. And then finally, the last thing I want to show you on this slide is I said the main objective of this trip was to survey. And so the real objective here was to use GPS measurements. This is GPS. It's a mapping system that we use to study our planet. And we were using this little receiver here to validate measurements of satellites as they collect data from space. So this is our GPS, and it's communicating with satellites hundreds of kilometers up in the sky. Pretty amazing. And these satellites can do some really cool stuff. So starting with that first point of, has Greenland always been so green? We're able to use GRACE, that's the name of this satellite, really beautiful name, to study how much change is going on in Greenland. So I'm going to play this little video. And if you watch this map of Greenland, you can see when it gets yellow and then orange, then red, that is showing places where Greenland is losing ice, either due to melting or breaking. And so it's rapidly changing, right? We're rapidly losing ice in Greenland relative to the previous year. So this little chart shows over the past 20 years, the pretty steady decrease in ice, right? That's a nice downward line. So that's something we really have to consider when we think about what's going to happen in a warming world, right? Greenland might just look very different than it did in 2014. Not so far into the future, kind of intense. So these satellites obviously can make a much better map than I can. Here I am on the summit of the Greenland ice sheet again. They can make a much more comprehensive map. They can cover the whole ice sheet, as opposed to me on a snowmobile and me on skis. I can't cover that much ground. I'm not that fast, and I'm not that high up in space. So this is something to consider. these satellites, they do a really good job mapping change. They cover a spatial scale that is so impressive and so useful. So now I really want to take you over to Alaska and show you how varied glacier ice can look and how many different things can be learned from these glaciers. So this is a glacier in Alaska called Echo Glacier. And here's a little channel. You can see this water here. It's kind of melted the side of the glacier. And here's some of my students on skis in this little gully. So the really cool thing I want to show you here is how we can map annual layers of snowfall in glaciers. So this photo was taken in 2021. And if we count down, we've got 2020, 2019, 2018, 2017. You can really see these distinct layers, right? And so in that way, we can study past climate as the snow compacts and turns into ice over time. So this is a really cool way in which glaciers preserve a history of our Earth's atmosphere. That's a whole other subfield of glaciology that I don't even have time to research, but it's amazing to think of ways that we can relate past climate to current climate through this old ice. But back to crevasses. So I told you how amazing satellite measurements are, but they oftentimes only get a sense of the surface. And those big cracks on the surface of glaciers, those crevasses, are really weird. Here I am rappelling into a crevasse in Alaska. When we're trying to understand how these things work, how does ice both flow and break? We'll talk about that in a little bit soon. But understanding how these crevasses open and how they move through the glaciers and how water moves through them. If glaciers are melting, sometimes these cracks can serve as ways for the water to accelerate that melt. You know, they kind of create these open roads and open holes for rainfall to fall into, for melt ponds. So rappelling into a crevasse is kind of intense, but it makes for a really cool picture, right? So just behind, this is just behind where that photo was taken, but I love this picture of the Von Lewis Glacier in Alaska. This is actually a place that you can go study. So if you get excited by this talk, when you're in college, you can apply to go study. You can see these little shacks over here. So students are able to go here and study climate change. And so I was a teacher at this place 2 years ago. But here on the Von Lewis Icefall, you can see this amazing way in which the glaciers, to me, look like a river, right? It looks like they're just flowing through this valley. But then if we look in the bottom left corner, we can see those crevasses, those big cracks. And so reconciling, how can ice do both of these things? How can it break like a very brittle object, like shattering a pencil, and flow like a river at the same time? This is a whole other field of research called material sciences that is really cool and something that you often aren't exposed to until college. So this motivates a ton of my work. How can a material, how can glacier ice be like a liquid flowing and shatter like a solid? So this is my favorite glacier. I love this glacier, Elephant's Foot Glacier in Greenland. How cool is this? It looks like honey, right? It looks like someone spilled a jar of honey. I just can't believe how cool this glacier is. There's another one coming up that is my second favorite glacier. So Elephant's Foot Glacier showcases this fluid behavior so well. But then remember, you drop an ice cube out of the ice cube tray and it just shatters. This is the same material. So we're going to watch a video. This is Exit Glacier in Alaska. And this is a time lapse of its movement through the summer. So you can really see, this is also a glacier in a national park in Kenai Fords. And so you can take tours of this glacier if you ever are able to go to Alaska. Very accessible glacier, so it's cool, you can go up to it. But if you watch this video in the middle, you can see the ice moving very fluidly, like a liquid, right? Then if you look on the side, whoop, you can see these cracks kind of growing and expanding. So ultimately, I think of this behavior as oozing, right? It's a little bit like slime. I know slime is pretty popular right now, and that's a lot of what glaciers are like. So back to coastal Alaska, this is the end of the Taku Glacier, and you can see it flows into a big floodplain. You can see all the melt that's coming off of the glacier, and then all of the crazy cracks on the surface. And so this is the big question for us glaciologists. How can ice be like oil or glue or shampoo or lotion or jello or rubber or wood? So we got to pick something. We have to figure out how can we relate glacier ice to a more well-known material. And ultimately, this is what I'm working on. Thinking about ways that we can identify a mathematical equation for ice movement. This is super important for thinking about how Greenland is melting or how Antarctica is changing. Using math, we can incorporate into models to understand sea level rise and a changing climate. Okay, that's the big takeaway. That's the big goal. But just to really get the point across, this big crevasse field on the Von Lewis Glacier, you can see how brittle it looks. Like I just shattered a pencil, right? Looks like ice cubes in a freezer. And then over to the Malaspina Glacier in Alaska, it looks like a liquid. So this is all one material, and we're really trying to understand how we can find a mathematical equation for this behavior. And this brings us back to satellites, because satellites do a way better job collecting data than I do. So all the way in Antarctica, this is the Brunt ice shelf. This is the glacier that I've spent the most time with on a computer screen for my PhD work. So the Brunt ice shelf is all the way up here, and it's pretty cool because the British Antarctic Survey has maintained a research station on this ice shelf right around here for the past many decades. So this picture, or this GIF, is a collection of many, many satellite pictures. Every week, the satellite rotates around Earth, or flies around Earth, and takes a picture. And as a result, we're able to understand not only the flow of the glacier, but also these big cracks. For the first time, really, we're able to get a sense of these cracks and get resolution, so get consistent pictures of crack growth. There's another crack right here that's a little more subtle if you follow these orange arrows. And this is a really helpful way that's getting us closer and closer to understanding glacier movement through mathematical equations, right? And so it's a really exciting time to be a glacier scientist, because this is a satellite or a rendering of a satellite that's going to launch in less than a year. This is NASA's latest satellite, and I'm so excited about it because this is going to give us every 4 day pictures of Earth's glaciers and the rest of Earth. But one of the coolest things about being a glacier scientist right now is that there's tons of very basic questions. How do glaciers flow? How do glaciers break? What is driving glacier change? Are they melting from the ocean, or are they melting from the atmosphere? These questions are ready to be answered by you all. And so there's tons of research that we are waiting for people to get into. It's a really small type of science, and it takes you all over the world. But ultimately, satellites are helping to make my job a little easier by being behind a computer instead of in a crevasse. So I'm really excited about my work, and I hope you are too. That's what I've got for you all, and I'm really excited to take your questions.
Well, we have some absolutely amazing questions, Joanna, and we are so glad that you're sitting with us here today instead of rappelling into a crevasse. That was such a cool picture, but I'm really glad to see you in your apartment. So to kick us off, I wanted to ask a few more questions about these glaciers and how they move.
Yeah.
So you mentioned up top in your presentation that, we're thinking about the movement of these glaciers in the context of global warming and climate change. So one of the questions I'd like to ask is, how do these glaciers move when we don't have global warming? Do they move more quickly or more slowly? How is global warming affecting how these glaciers are moving around today?
So I'm going to give you the most annoying answer. It depends. And global warming is, at least what we know, speeding up surface melt in Greenland. So melting from the surface, And it's also creating warmer waters in places like Alaska and Western Antarctica that's melting glaciers from underneath. So we're sure of that. But glaciers can behave in all sorts of weird ways. And so we haven't had enough satellite data. We don't have a long enough observational history to understand how these glaciers used to behave. We can be sure that in periods of ice ages, there was a lot more ice. There used to be an ice sheet covering almost all of Europe, almost all of North America, but in terms of their day-to-day speeds, we're not sure.
During this era of global warming, and you mentioned that there's these cracks in these glaciers and they let in rain and they melt. Is that bad for the overall state of that glacier? Does that mean it's kind of going downhill, going to lose a lot of water?
Yeah, that's what we think. Again, it's so hard to look into these crevasses. So beyond what we can see from the surface, or me in a crevasse, we're not sure how deep it goes. These glaciers are thicker than entire skyscrapers. They're hundreds of meters thick. And so once that water gets into the surface, it either turns into like a braided river system or a really focused channel. And so we think that the more water there is, the faster that melt comes together and forms an efficient channel, melting the glacier more quickly. So it's not a pretty picture. It's not a happy story.
Yeah, no, that sounds definitely really tough. So we have a student who's wondering, why, here's what the Nord Anglia student says.
Yeah.
I don't really like snow and cold weather. Why is it so bad that this ice is melting in the first place? What does this mean for us here on?
I totally feel it. Well, so I also thought I didn't like snow and cold weather, but there's a Norwegian saying that I love, that there's no bad weather, just bad gear. And there's something amazing about having a huge coat. So that has totally changed my feeling about winter, but it really matters. So this is the thing. It really matters that these glaciers go away because they help stabilize the greater atmospheric and ocean circulation. And so if the glaciers go away, the atmosphere will totally change, ocean patterns will change, and that could create disastrous or really confusing changes to the climate system. And so we really don't want to see a world in which living in, kind of warm weather and where you've got t-shirt on and jeans turns into sweltering heat all year, right? I'd rather take being cold a few months of the year than being really, really sweaty all year. But that's just me.
I think I agree with you there.
Yeah.
Initially about that really lovely saying about how, the gear and what you have to be in that environment is just so important to your experience. Can you tell us a little bit about what it was like to actually be on a glacier? I mean, where did you guys land in your helicopter? What did the ground feel like? Was it like freezing outside?
So I think one of the craziest feelings was landing or showing up on a glacier for the first time and not being that cold. So let's talk about that 2014, that first trip to Greenland. It was in June. And in June in Greenland, that far north, the sun is up 24 hours. So it's never dark. And as a result, it's kind of disorienting. You're not really sure when to go to sleep. We would work and be outside all day. And then we'd realize, oh my goodness, it's 10 p.m. We should probably eat dinner. So it's kind of disorienting. And it was also pretty warm, So I was in that picture of me in the red coat. That's like just a little shell. It wasn't like I needed a big parka. Sometimes I needed a big parka, but there were often times I wasn't even wearing gloves. But the big thing that I also remember and always think about on glaciers is that snow and ice is very reflective. And so you need to wear so much sunscreen. You forget that if it's cold and windy, you don't always think to wear sunscreen, but I would get these horrible sunburns underneath your chin because that's where light would reflect up from the snow. Yeah. So a place to never forget to wear sunscreen.
That is really, really good to know. So for the Nord Anglia students on this call who are going to be
Yeah,
glaciologists, sunscreen here, okay? Don't forget
yeah,
it.
everywhere.
Everywhere. We have a follow-up question from another Nord Anglia student, and they're wondering, do you have to be a good skier to get around on a glacier?
No, no. So I'd never skied until becoming a glaciologist. And I think that's the big thing to remember is all of the gear, all of the skills, these are all learned and provided from by mentors and by like the US polar programs, things like that. So none of the gear I needed to buy myself. And that's a big thing to remember. You don't need to be really outdoorsy. I'd never gone camping until I started doing this. I never really liked hiking. I didn't really like being outside that much until I realized gear was a big part of it. I didn't have the proper equipment, but also I didn't need to take on that burden myself. So you don't need to be a good skier. I think that if you're a good skier, maybe that helps, but I'm not a good skier and I feel like it's worked out okay.
And between skiing and using a snowmobile, which one do you like more? Because you showed us a photo of both.
I think skiing. I like skiing a lot more, but snowmobiles have thumb warmers, which are like the little hand warmers, which is a nice addition. So that was cool.
That is really neat. So now we have a couple of
Yeah.
vocabulary questions from a Nord Anglia student. So they want to know, are icebergs and glaciers the same thing?
Okay, so I really skipped over a lot of this specific wording, and I'll go through it right now. So we'll start big and move small, if that's okay. Ice sheets are the biggest thing that we can have on Earth. So ice sheets is a collection of many glaciers and many ice fields, which is a collection of just a few glaciers. So ice sheets are continent size. Then the next layer smaller is ice caps. Just a little smaller, same thing, many glaciers. After that, we have next layer smaller, ice fields, and that's maybe a dozen or so glaciers that all flow together. Then we have individual glaciers, and then we have icebergs. And icebergs are just the detached floating chunks of ice. So after a crevasse has kind of gone through the entire thickness of the glacier and calved off. That's the word that we use for saying that it's broken off into the ocean and it's floating on its own. That's an iceberg. So the big difference here is that iceberg is floating on its own and it's probably just going to melt because of the ocean and the warm atmosphere, but it's disconnected from the ground.
Got it. Okay, thank you for clarifying that. I think those are all really, really cool terms. And some of the students in the chat are mentioning the Titanic movie where they learn about an iceberg.
Oh, yeah.
There. So that's really good clarification to know that it did indeed come from a glacier that calved. And
Yeah.
speaking of all of this really cool dynamic movement you've been showing us that's happening to these glaciers you visited, we're wondering, when you're out in that environment, did you hear anything? Can you hear glaciers move? Do they make sounds?
Yes, it is really cool. When a glacier breaks off, that calving, to form an iceberg, you hear that sound of breaking echoing, and it's so loud and vibrating, and it's just, there's nothing else around. There's not, you don't have someone with speakers and cars and the sounds of a city. So it's really loud, and it kind of sounds like, do you know when your stomach rumbles and kind of makes that noise? It's like that, but in your ears. That's how it sounds. Yeah, pretty fun.
That is really, really cool. And now we have a question from a student who I think is referencing those layers in that glacier you showed us. And they're wondering, what can we learn from those layers? Can we study Earth's past environmental history using that?
Yeah, so this is really, really amazing. As snow falls on the surface of the glacier and compacts into ice. So basically, the only difference between snow and ice is density. So just how compacted it is. So snow falls, gravity compacts it into make this nice tight little package. And in doing so, it traps a few air bubbles. So those air bubbles preserve things in our climate, in our current atmosphere. And so when we look at past layers and collect the data from those tiny little air bubbles trapped in there, we can understand what the atmosphere, what chemicals were in the atmosphere hundreds of years ago, thousands of years ago. It's pretty amazing.
That is super cool. And I mean, you know, I'm trying to study ancient Greenland's environmental conditions in my own research. So
exactly,
I'm taking note of what you just said right over there.
Unfortunately, I think we only get maybe 100,000 years old.
Oh, I'm only studying the past 2000, so we are covered.
That's perfect. Oh, yeah.
That's fantastic. So we have a student who's wondering about the temperatures in this environment. So you told us, you know, you've gotten off the helicopter, you've landed, you know, on this glacial environment, and it's surprisingly warm out. But this student's wondering specifically about the ice itself. Is glacier ice colder than regular ice? Is there something special about how compact it is, maybe?
Not really. Glacier ice, the exact same type of ice, but ice has this really cool ability. Ice and snow have this really cool insulating ability. So if you ever get the chance if you ever get the chance to go winter camping, I know doesn't sound super appealing, but something that you can do is build a little snow cave. So you can dig out a bunch of snow and get in there, and you'll be like, wow, it's pretty warm in here. So ice and snow insulate really well. You know, you hear about root cellars, things like that, where like in the ground can be a little bit colder. But yeah, ice has this really amazing ability that like when you go a little bit deeper in a glacier, it gets a little warmer and then it gets colder again. So kind of goes from cold to a little warmer and then back to cold. It's weird. It's really weird.
That is super cool.
Yeah, it's amazing that we have like this one molecule, water, can do so much.
Yeah. And I mean, for the students, you know, during the next big snow, if they want to try it with your parents.
Yes.
It can be kind of dangerous to dig up the kind of ice and snow we have here when we're not on glaciers. So just be really careful if you want to try it out. But you can also read about it with things like igloos as well, and in these kinds of really cool environments. We have a few questions from students who are so curious about your fieldwork still.
Okay.
They're wondering, did you ever make a snow cone with glacier ice?
Yes. Definitely ate some of it because if you're there, you have to, right? Like, I think I was just like, I've got to try this. Something that I think about all the time is one time I was on a snowmobile and I had M&Ms in my pocket and they fell out somewhere on the Greenland ice sheet. And I just always think about those M&Ms are going to be trapped in the ice for many, many years. And maybe someone will find them many years from now and wonder, what was going on here? So I always think about those M&Ms.
That is way too cool. I mean, yeah, you've just like put some fossils in the
I know, it's
record for later. That's such a funny thought. You know, when you were traveling there, did you guys bring water with you, or could you just melt the ice and drink it?
Oftentimes melt the ice and drink it. Yeah. You know, you just need, if you have a water bottle, if you start with a bottle of water and you put a little bit of snow or ice in, it'll melt. So if you start with just if it's mainly water with a little bit of ice, it melts. And so that's what you just keep replenishing that way.
That is too neat. And sounds really refreshing, actually. So that's nice.
Yeah.
So I wanted to turn our attention a little bit back to the materials science questions that you're kind of trying to ask.
Okay.
So you're working on finding mathematical equations to describe how these glaciers move. And you mentioned during your talk that, you know, there's a connection between, you know, glaciers and honey and the fact that they both can flow. Can you just tell us and reiterate a little bit about that connection between honey and glaciers? That sounds so sweet.
Yeah. So I like to use honey as the example because it's the most appetizing, right? But glaciers, so glaciers are moving really slowly. Like in the grand scheme of things, they're huge, but it's the fastest glaciers can be moving maybe a football field a day. That's a lot. That's a lot. But when we're trying to think about the glacier honey connection, it's just the idea that this material can ooze and flow through topography, flow through our landscape without being interrupted. So the glacier, as it moves around things, preserves its kind of whole shape. So that's why we can sometimes think about glaciers as a fluid or a liquid.
Got it. And then could you describe to us, now that you're, back on land and you're doing this really, cool satellite data now and working on this math, could you just tell us what a day in the life of glaciologist Joanna looks like?
So right now, day in the life looks like a lot of writing. So I've created tons of data sets and thinking about how glaciers are changing using this spatial satellite data. And now I'm writing it up for publication, right? So that's a big part about being a scientist, is sharing your research to other scientists. So writing that up, I don't love writing. I think it's pretty hard. And so something that I do to kind of help kickstart that process for me is talking to people, either other glaciologists or other scientists or other just students. I love teaching and sharing information. I think it helps kind of get concepts in my brain and better communicate them. So that's a little bit what my day in the life looks like, writing and talking a lot about what I'm writing about, also biking to help clear my head.
Yeah, can you tell us about how often you bike and how long have you been doing this? I think you showed us a picture of you competing.
Yeah,
as well.
I have been biking since I was about 16, I think. And I bike almost every day. And I just love it. The longest ride I've ever done in a day is 150 miles. And I just love biking really long distances. I think it's so fun. And also one of the best things about biking is the snacks. So I eat a ton of candy while I'm biking, and that's just the best if you're me. I love candy.
Is it like M&Ms in your pocket when you bike too?
Yeah, it is. It's not too dissimilar. It's a lot of gummy bears.
And now we have a couple of Nord-Anglia students who are kind of curious, bringing it back to education here.
Yeah.
Why did you follow this path at MIT? What brought you to do your PhD here?
So as you all can imagine, because I bet not many of you have met a glacier scientist. The glacier science community is pretty tiny. And I came to MIT particularly to do my PhD because my advisor, his name is Brent Minshew, does really cool work with satellite data. Instead of just thinking about pictures we can take from satellite data, he thinks about how we can take two pictures and look at change between the two of them and look at like really subtle differences between two images. So I really wanted to learn how he did that. And I thought he'd be a really fun person to hang out with for 5 years. Doing a PhD is a lot of time to spend with one person, so you better like your advisor.
I think that's really, really good advice. Now, Joanna, speaking of advice, and we have some really awesome questions in the chat, but unfortunately we don't have time to answer every single one of them. But I want to ask you one more question before we go.
Okay.
And there's a lot of students who are just asking such cool, enthusiastic questions here. And I get the sense that some of them might want to be glaciologists themselves one day.
Please do.
Yeah, I'm all for it. Could you tell them, what are some good qualities that glaciologists have, things that these students can think about as they pursue their educations?
So I think something to remember is that you don't need to be outdoorsy or a skier or anything. You don't need to be that way to be a glacier scientist. But I think the most important thing, if you really wanted to study glaciers, is to like maps, is to be excited about maps and really curious about the world around you. I think that one of the one skill, I'm sure that on a lot of these MIT abstracts, people say learn math and science, and that definitely helps. But learning how to read a map is such a cool skill that is not always necessary anymore. And so I really urge you all to like look at some maps, think about topography, think about landscape. It's such a cool thing to do. Maps are amazing, and you can learn so much from them, from history to geology.
I totally love that answer. And so folks, you have it here from Joanna, go out, find those maps, look on your parents' phones, find the, printed maps, go to a museum that has big maps. I mean, so much cool stuff there that you can see.
Yeah.
I know I love looking at maps as well.
Exactly.
They're one of my favorite parts of geology. So
that's the thing. All earth scientists love maps. That's, I think, the one thing that unites us all.
I think that's totally wonderful. So now I want to thank you so much for your time, Joanna. These were super amazing questions. Thanks for joining us today. I want to quickly tell our listeners today about the coming abstract. So let me quickly give you guys a snapshot of what that's going to look like. So up next, we have some totally wonderful MIT abstracts. Join us next month to learn about stars and jars with Sean Mackey. He's a graduate student here at MIT as well. And now I just wanted to thank our audience for being so stellar, so amazing, so cool, asking wonderful questions. As always, thank you, Joanna, for spending time with us today, letting us go on this really cool adventure with you. And lastly, I wanted to thank the folks who make this series possible, the MIT Nord Anglia Education Collaboration. Appreciate it a lot. Thank you all.
Yeah, thanks so much for having me. What a blast.
Yeah, have a great day, everyone. Goodbye.